Welcome friends. Let us continue to study heat engines on my YouTube channel. Kindly like, share and subscribe my YouTube channel. The topic included in today's lecture is numerical on Carnot cycle having working medium air. A Carnot cycle is working between temperature limits of 1990 Kelvin and 850 Kelvin. Calculate the efficiency of Carnot cycle. So they have given us the two temperature limits. One is 1990 Kelvin and another one is 850 Kelvin. So out of these two temperature, which is the temperature of heat source and which is the temperature of heat sink? Can anybody say? Yes, that is the heat source temperature is 1990 Kelvin, that is T1 or TH, and 850 is the temperature of heat sink, and it is the represented by the symbol T2 or TL. So now they have given us T1 or T2 and then they have given us or TH and TL. Now let us calculate the efficiency. What is the equation to calculate the efficiency of Carnot cycle? Yes, that is 1 minus TL by TH. So the equation is 1 minus 850 divided by 1990. So the answer is 57.29% is the efficiency of Carnot cycle air. Now let us solve the another numerical. A hot air engine works on Carnot cycle with thermal efficiency of 70%. If final temperature of air is 20 degrees Celsius, determine initial temperature. It means they have given us the efficiency of Carnot cycle and they have given us the final temperature of air, that is working medium. Now what do you mean by final temperature? Whether they have given the temperature of heat source or heat sink. Efficiency of Carnot cycle, that is equals to 0.7, and as it is the final temperature, it means they have given us the heat sink temperature T2 or TL, that is equals to 20 degree Celsius. Now we are required to convert the temperature in Kelvin. So converting it, we are going to get 293 Kelvin. Now we have to calculate the initial temperature, that is TH. So now we will use the equation of efficiency of Carnot cycle, that is equals to 1 minus TL by TH. Substituting the data, 0.7 is equals to 1 minus 293 divided by TH. On calculating, we are going to get the TH is equals to 976.67 Kelvin, or that is equals to 703.67 degree Celsius. Now let us solve the another numerical. A Carnot heat engine operating between a high temperature source at 900 Kelvin and rejects heat to a low temperature reservoir at 300 Kelvin. So they have given us the two temperature, that is high temperature reservoir, that is heat source temperature, and heat sink temperature. Determine thermal efficiency of heat engine. And second, if the temperature of high temperature source is decreased incrementally, how is the thermal efficiency changes with the temperature? Now let us solve it. Data given, heat source temperature, that is T1 or TH is equals to 900 Kelvin. Heat sink temperature T2 or TL 300 Kelvin. Thermal efficiency, the equation is 1 minus TL by TH. Substituting the value 1 minus 300 by 900, and therefore the answer is 66.7%. That is the efficiency of Carnot cycle. Now let us see what they have asked in the second part. If the temperature of the high temperature source, that is heat source, is decreased incrementally, it means initially they have given 900. Now if it is decreased from 900 to, let us say it is 880, then 850, then 820, then 800. That is what it means to say. How is the thermal efficiency changes with the temperature? It means if the heat source temperature reduces, what will be its effect on the efficiency? Keeping the heat source temperature same, that is T2 or TL will remain same, that is 300 Kelvin. So T1 or TH is 850 Kelvin, 800, 700 up to 300 Kelvin. TL is 300 Kelvin. And what will be the efficiency? So now let us calculate. So if it is 900 TH, it will be 66.7. That already we have derived. If we reduce the heat source temperature to 850, at the same TL, we are going to get the efficiency of Carnot cycle is 64.71. If we reduce it again to the 800, we are going to get the efficiency of Carnot cycle is 62.50%. If we reduce it again, it will be 60%. If we reduce again, it will be 57.14%. And on other further reduction, it will be 53.85%. If we continue to reduce up to 300, we are going to get the efficiency 50%, 45.45%, 40, 33.33, 25, 14, and with the same temperature as TL. If the temperature of TH and TL are same, efficiency is 0. Now let us represent this fact using the graph. So this one is the graph. If the temperature, that is you can say heat source temperature reduces, its efficiency also reduces. Or in other way, if we say that if the heat source temperature is increased, efficiency of Carnot cycle also increases. Now let us, you can say, study the same thing, the effect of low temperature heat sink. It is not asked in the numerical, but let us study. So now let us study the effect of low temperature source on thermal efficiency, keeping the heat source temperature same. So heat source temperature is 900, and these are the different values of the heat sink temperature, and the efficiencies are like this. At the TL 500 Kelvin, efficiency is 44.44%. And if the TL reduces, efficiency, you can say 52, 50.56, 61.11, 66.67, 72.22. It means when the TL reduces, the efficiency of Carnot cycle increases. Now let us again you can represent the same thing on the you can say graph. So if the temperature of heat sink reduces, efficiency of the Carnot cycle increases. Or in another way, if the efficiency of the heat sink increases, the efficiency of Carnot cycle reduces. And if the temperature of heat source is higher, it becomes more difficult for a heat engine to transfer heat into heat. It means heat sink temperature should not be higher, it should be lower. It lowers the thermal efficiency also. And therefore, heat sink such as a river or a lake are popular for this region. It means heat is rejected to rivers or lakes. Kindly mention your queries in the comment box. Kindly like, share and subscribe my YouTube channel. Thank you.